In the last 50 years of exploring Mars, we've gone from thinking maybe there were canals and aliens that had created this whole ecosystem, transporting water from the polar caps toward gigantic farms, to getting there and seeing these pictures of just cratered landscapes, the surface that's baked in radiation, barely an atmosphere to speak of, not a place that could sustain life as we know it.
We look at the planet Mars and it's this rusty red ball. And it doesn't look like it's a great place for life to live at all. You know, stagnant.
When I was a kid, Mars looked incredibly dead and it was boring. The end. Close the book, don't ever go back.
I think when the general public thinks of Mars, they imagine this dead red rock where we haven't found any evidence of life. So why do we keep exploring? Why do we keep sending these missions there?
Mars nam baš i nije pomogao ostvariti snove o pronalaženju života izvan Zemlje. Ali, hoće li se to promijeniti? U sklopu NASIne misije uz pomoć terenskog vozila Perseverance možda ćemo napokon otkriti jesu li na površini Marsa nekoć boravili organizmi.
Perseverance, it is an entirely unfamiliar kind of mission. We've never done anything like this before.
This feels like a revolution right now in our understanding of Mars.
Whether Mars had life is the question. If it did start there, maybe life is really easy. If it didn't start there, maybe life is really hard.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Touchdown confirmed. We're going to wait for the images.
The second we landed, then we actually started getting to work as the images started coming down.
Perseverance is continuing to transmit. Yes!
Are we alone in the universe? And that's what we're trying to figure out. That's what exploration's all about.
Godine 2012. terensko vozilo Curiosity, prethodnik Perseverancea, pošlo je u misiju kojom je trebalo utvrditi jesu li na Marsu ikad postojali uvjeti u kojima bi mogao opstati život kakav poznajemo. Bio je to važan prvi korak ka traženju života.
When Curiosity is driving around, it's driving over rocks that are billions of years old. Now, Curiosity is not designed to actually look for signs of life, but it most certainly can identify an environment that has everything that's necessary for life to be there. I'm interested in knowing if there are organic molecules in the rocks that we encounter.
Curiosity je bilo prvo terensko vozilo s minijaturnim laboratorijem kojim se mogu otkriti organske molekule.
Organic material is critical for life as we know it. So if we don't find any on Mars, that's a huge deal.
Mars is just so inhospitable. The surface is being bombarded by ionizing radiation, which is not good for life or organic molecules. Not good. It tends to break them down. Every sample was a bit of a risk, scientifically, because we didn't know what we were going to come across. I mean, there were samples where we really didn't learn much of anything.
If we had the conditions for life to survive, we would expect to find organic material. We still hadn't seen any with Curiosity, and this was a big mystery. Was there never any organic material on Mars?
Our best hope was to just keep looking. We came across a bunch of cobbles and stones that were all rounded. And the best way of doing that is in a river. We realized there had been water flowing on the surface of Mars in the past. Then we knew we were on the right track. We were heading to where we thought the lake was. We saw these features, and they sort of indicated that there was shallow water Shallow water is a great place for life to do its thing, get immediately trapped into the sediments. So I was particularly interested in that sample. And when we drilled into the first rock, the sediment was dark gray. It hadn't been rusted like everything else you see on the surface of Mars. And there was a window into the past. There was organic matter in that rock, and that it had survived eons of ionizing radiation at the surface of Mars.
Otkriće organskih tvari velik je korak kod utvrđivanja mogućnosti nastanjivanja Marsa, ali ne dokazuje postojanje života na njemu.
Finding organics is not proof of life on Mars at all. It's a nice hint, but we don't know whether these organic molecules actually rain down on the surface of Mars in the form of meteorites over time.
Okay, great. We finally have found organics on Mars, but it doesn't tell us anything about where those molecules came from and what they're doing there and what they mean to us.
Because of missions like Curiosity, we know that Mars was absolutely habitable. So the next question is, was it ever inhabited?
Na Zemlji se priprema potpuno nova misija.
The goal of the Perseverance rover is to look for signs of ancient life on Mars. We finally put together the pieces of what Mars used to be like, and we know what evidence we need to definitively say whether there was or wasn't life on Mars. So Perseverance's goal is to take us to that next step.
The purpose of Perseverance rover mission is to find some ancient traces of life on Mars, and for that purpose, the instrument needs to be different from the Curiosity rover, and we need to have more techniques to meet this requirement. And that's the price to pay to be on board.
Ali kako početi nalaziti tragove koji upućuju na život? Na kraju robotske ruke Perseverancea postavljen je instrument nazvan Sherlock, čime je razina istraživanja organskih molekula koje je bio proveo Curiosity podignuta na višu razinu.
Curiosity has a mass spectrometer, and that's one way of detecting for organic molecules. What we do is something a little different. We are looking for spectral signatures. We shine a laser on a surface, and then we look at the backscattered light coming back, and how that light changes tells us what's in the surface. Detect and classify organic molecules on a very fine scale.
The astrobiologists are going crazy for this instrument because the wavelength at which the spectrometer operates is optimized for organics.
Na robotskoj ruci na kraju, suprotnom od Sherlocka, nalazi se instrument Pixel, temeljito preobličeno osnovno geološko oruđe.
I sometimes refer to it as a chemical hand lens. The hand lens being the eyepiece the geologist uses to look at the rock. Imagine being able to look through that and see not just what the rock looks like, but also what it's made of.
Pixel s pomoću spektroskopije izrađuje kemijsku mapu površine kako bi se vidjelo je li u stijeni bilo znakova života.
In a way, it looks like a camera image, but it is really the fingerprints of the rock, and in turn, those fingerprints tell you the history of the rock, how it was formed, what environment it was in.
The Pixel instrument was something that arrived from doing field geology out in Western Australia one year, trying to look for evidence of life in the oldest rocks on Earth. I found that trying to figure out on Earth whether something that was in a rock that was possibly biological was actually biological was really helped by this instrument called an X-ray microscope. It's like a pretty decent-sized beach ball. It's connected to the mains power, and of course, if anything goes wrong with it, then you get a crew come out to fix it. The most challenging aspect of building Pixel is the not being able to break. You have to be able to get it off the surface of Earth to Mars, land on the surface of Mars, and then survive on Mars for the entire prime mission and hopefully well beyond. All of that had to be done in addition to getting it down from 80 centimetres cubed to about 20 centimetres cubed. There were certainly moments where it was like, oh my God, how complicated is this becoming?
Prilagođavanje preciznih instrumenata za budući rad na Marsu smiona inženjerska zadaća, čak i za one koji su to već prije radili.
Oh, to develop an instrument from Mars is pretty easy. You just have to worry about every single thing, down to the bolts and where the bolts go and where the bolts don't go. Most instruments that are Sherlock-like do not like vibration, and we're attached to a drill that vibrates. The temperature swings on Mars every day is 100 degrees Celsius. Electronics really don't like to be hot, then cold, then hot, then cold, then hot, then cold every single day.
Osim nesmiljenosti Marsove atmosfere, letjelice moraju izdržati i nedaće leta u svemiru do cilja.
We do testing, informally known as shake and bake, right? Because you want to shake it and you want to heat it.
Everything that goes into space has to be really thoroughly tested. You could almost say violently tested. We vibrate it at different frequencies and make sure no screws come loose, nothing falls apart.
When I saw the shaking, I was like, my God, what about the optical alignments? It's a bit heartbreaking to see your instrument suffering like that.
Najvrednija je u nizu instrumenata Perseverancea upadljiva superkamera.
Supercam is often described as the head of the rover, and it is. It's sort of this cyclops laser eye.
Laser dugog dometa na superkameri, čija zraka prodire u kamen, mogao bi unijeti veliku promjenu u potragu za životom.
We can shoot the laser at a rock up to 7 meters away from the rover. So we can actually analyze things all around us without having to drive up to it.
The rock gets literally zapped, and the atoms come screaming off at 10,000 degrees in a plasma. And then with that cyclops eye, we collect some of that light. We can tell what are the chemical elements that are present in that rock.
It blows my mind that a scientist in a lab one day thought, let's blow up rocks with lasers and see what they're made out of. And now we're doing this on Mars.
Tik ispod superkamere montirane su dvije stereoskopske kamere za navigaciju vozila na terenu, kojim vozač upravlja s pomoću posebnih 3D naočala.
So as a rover driver, I'll put on my 3D goggles, and getting the three-dimensional data allows you to really visualize the terrain in order to determine if something's a hazard. And on Perseverance, the cameras are fantastic, very high resolution, so we'll be able to see a lot further.
Kompleksnu optiku za superkameru i cijelu glavu Perseverancea izradila je francuska svemirska agencija CNES u gradu Toulouseu. Potkraj 2018. lansiranje je na vidiku. Ali budućnost nasina kiklopova oka uskoro će biti dovedena u pitanje.
We had a phone call every Tuesday with GPL. We had a small modification to do on the instrument just before delivery.
We were actually on the phone talking about final touches that they were doing on this beautiful masterpiece.
And it happened during this phone call. My test team in Toulouse called me saying, we have a big problem.
Posljednja faza modifikacije u superkameru toplinska je obrada ljepila korištenog u završnom montiranju.
To make sure that the bonding is done correctly, we put the instrument into a small oven and we bake it at 50 degrees Celsius. That's what we did. But we had an issue with the hardware, the thermal chamber.
The thermocouple in that furnace broke, went to its maximum temperature.
It was a disaster. Basically, we destroyed all the optical parts of the mast unit 2 months before delivery to JPL. I was still on the phone call with JPL.
We started to realize that the people on the phone in France were very distracted. They said, this thing is destroyed. And we had just a few months to go.
If something breaks on your flight model, that could actually end your mission.
Part of the problem is the launch window for Mars opens up every 26 months. If we miss this launch opportunity, we got to wait 26 more months.
Probably Mars 2020 will launch without us. But that's where we are. Now, what can we do?
Superkameru je trebalo otpisati. Ekipa se sad mogla samo nadati da će u roku uoči lansiranja nekako prenamijeniti postojeću opremu, a za to ima samo jednu priliku.
In parallel to building the SuperCam flight unit, we were also building a laboratory unit, almost identical, so we could do experiments on Earth during the mission. We had to take that laboratory unit and try to make it flight-worthy.
But we had to constrain everything in 6 months instead of 1 year taken to build the first model.
It is really a last-ditch effort. It was like, oh, we've gotten this far, and then we're not going to make it.
We had to work days and nights, the weekend and everything. But in 6 months, we had a new SuperCam mass unit. Honestly, I'm so happy to see the performance of the instruments. It's really a perfect instrument.
Dok se priprema lansiranje Perseverancea, misija ulazi u najneizvjesniju fazu, gdje povijest ima spremne lekcije za one koji se odluče otputiti u druge svjetove.
Getting to Mars is no easy task. You have 2 moving targets, Earth and Mars, and then you're throwing in the 3rd moving target of the thing you're trying to get from one planet to the next at thousands of miles an hour. Schiaparelli was a technology demonstration, a tiny lander that was Europe's first attempt to land on the surface of Mars.
Everything had been going right up till the point of parachute deploy. Supersonic parachute inflation, that's a very violent event. It was swinging too fast underneath the parachute. Couldn't figure out which way it was up. Unfortunately for Schiaparelli, it was like stealing defeat from the jaws of victory.
Schiaparelli ended up smashing into the surface of Mars and left a nice little splot in the dust that we could see from orbit.
Schiaparelli hit the ground going much faster than it was designed to do, and we call that creating a new crater on Mars. And we felt, really horrible for them, because, there's years of work that went into that.
It was a terrible feeling. It was just like another crash on Mars, and we could be next.
The team on Perseverance looked at Schiaparelli as very much a reminder of just how hard this really is.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Raketa Atlas, visoka 58 metara, dovoljno je snažna da terensko vozilo mase 1 metričke tone prenese na Mars, kada je najbliži Zemlji. Let će svejedno trajati 7 mjeseci. Znanstvenici dokle pozornost preusmjeravaju na mjesto slijetanja, za koje vjeruju da nudi najbolju mogućnost za pronalazak dokaza o životu iz davnine. Krater Jezero smješten je uz zapadni rub jedne od najvećih depresija na sjevernoj polutki.
If there was ever life on Mars, then a place like Jezero is going to be spot on, absolutely perfect to preserve evidence of life.
Jezero has long been on the list of top possible landing sites because it looks like there was a long-lasting lake, a body of water. But the problem is that incredible topography is also incredibly dangerous for spacecraft.
If you look at Jezero, there are just so many hazards. There's a delta with really steep clipped walls.
Scientists want to go to places that have a lot of topography, that have a lot of rocks. But as a guy who's trying to land a rover safely there, when you look at all those things, you just see danger.
Perseverance ima novu tehnologiju, terenski relativnu navigaciju koja prepoznaje opasnosti na tlu i izbjegava ih.
Train relative navigation means that Perseverance can tell whether there's a mound or there's a hill or there's some other thing that the rover could possibly land on that would be bad, and it steers the rover away from that. And that's the only reason we could land in Jezero crater.
Without this navigation system, you should expect that about 20% of the time, you're not going to make it.
Iako je nova tehnologija opsežno iskušana na Zemlji, sada će prvi put biti u funkciji zajedno sa sustavom za slijetanje.
It's humbling, right, to realize that the first time you get a chance to use your whole system is going to be when it has to work at Mars.
18. veljače 2021. Perseverance se sprema ući u Marsovu atmosferu. Sad kad je 470 milijuna kilometara udaljena od Zemlje, svemirska letjelica zbog kašnjenja u komunikaciji mora tijekom 7-minutnog postupka slijetanja djelovati autonomno.
That's 7 minutes from when you hit the top of the atmosphere, going 12,000 miles an hour, till we touch down. There's literally nothing we can do. We're just finding out what has already happened about 11 and a half minutes ago.
We have spent more than 6 years developing the instruments, and you know that in 7 minutes, everything can change. Either you have the rover on Mars, or you lose everything in 7 minutes.
Perseverance je prepušten sebi, ali na Zemlju šalje opis statusa u obliku tonskog koda, slično glazbenim notama.
So it's kind of like it's singing a little song to us on the way down. And each of those notes means something different. You know, if you hit this note, that means we deploy the parachute. Or if you hit this other note, it means something has really gone bad with something.
You wait for that telemetry to come back and see what it tells you. And if you're not getting the readings that you expect, your heart just sinks into the pit of your stomach.
10 minutes before we get to the top of the atmosphere, she tells us that something's gone wrong with one of the electronics boxes, one of the computers.
All stations at this point, let's limit our traffic on the net to critical issues only.
If Perseverance was right that something was wrong with that box, we would lose the ability to fire thrusters, and the propulsion system not working would be certain death.
Perseverance is actually being pulled in by gravity and accelerating.
The mission would be over, no question.
There's a lot of silence in the room. Everybody's monitoring that telemetry so carefully, knowing that we'd done everything we could, and yet this belief that it'll recover and we continue to have a mission.
The vehicle slams into the atmosphere, going about 5.4 kilometers per second. On the outside of the vehicle, we're getting white hot like the sun. All we can do is take a look at what Perseverance is telling us and worry. Are your engines really going to work? Or are we about to fall to our death? Luckily, the spacecraft began to do things that were consistent with the box working, because all of our thrusters seem to be working fine. So, crisis averted for the moment, but it definitely got our hearts beating.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration.
We had cameras all over the place looking up at the parachute. This was extraordinary. This was a documentary.
Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
We're approaching at the mercy of the winds and of the whims of the rockets. If we happen to land on a too large a rock, the mission is over.
Heat shield set.
Perseverance is now slowed to subsonic.
Our new system called Terrain Relative Navigation allows Perseverance on her own to figure out exactly where she is by taking pictures of the ground and matching them up with an onboard map. We light up rocket engines on that jetpack to slow us down and steer us to the nearest safe spot that we can find.
Our velocity is about 75 meters per second at an altitude of about a kilometer.
But right after that, you can hear one of my teammates call out TRN safety level Bravo.
TRN safety Bravo.
What that was telling us was that Terrain Relative Navigation has done its job, but the best place that it could land was not the best case scenario. It could no longer go to where we had originally targeted. That causes us to freak out again. Suddenly, you're thinking, oh, my chances just dropped to 1 in 20 that we're going to die at touchdown. Perseverance flew about 600 meters to the southeast to reach it. If one thing goes wrong, it's game over.
Skycrane maneuver has started.
20 meters above the ground. We deploy the rover and its wheels below that rocket-powered jetpack.
You have so much riding on this. Like whether as a rover driver, you're actually going to have a job, all depends on this landing.
It's nerve-wracking the whole time. All of those little black things that were coming by the camera, I called those projectiles that might have hit my instrument. That's the fear.
We had our fingers crossed all the way through touchdown that we had found a safe spot.
That sky crane let the rover touch the ground and then cut the cables and fly away.
Touchdown confirmed. Perseverance safely on the surface of Mars.
People are jumping up and down, elated. So to some people, landing looked perfect. But I mostly just felt a massive sense of relief.
As soon as they gave us a coordinate, we were able to load where the rover is. You're like, what is Jezero like? You're curious about seeing the terrain. You put on the 3D goggles and it really transports you as if you're on Mars, standing there from the perspective of the rover's cameras. It's very immersive. Jezero was really spectacular from the first image that came down. I think I did that for hours.
Once we landed, the first thing I said to my engineering team was, oh God, now it has to work. So our stress started increasing.
Stručnjaci provode kalibracijske provjere na instrumentima da vide jesu li ostali neoštećeni nakon slijetanja i isprobavaju lasere na obližnjim stijenama.
They went for a target just a few feet in front of the rover, made a nice target because we couldn't miss. We were crossing our fingers, praying that everything's going to work. When we saw the atomic emission spectra, that was the moment of truth.
Spektri su pokazali da je probni kamen bazalt uobičajen je u oceanskim bazenima na Zemlji i diljem Marsa. Rezultat potvrđuje njihovu slutnju da je to nekoć bilo drevno jezero. Ništa ne upućuje na mogućnost da je ovdje u zoni slijetanja ikad bilo života. No, Perseverance je samo nekoliko kilometara od spektakularnih tvorevina koje su ga dovele do kratera jezero.
So we landed right in front of a river delta. And what we're going to do is drive up this river delta, and along the way we're going to take samples and do scientific analysis on the rocks.
A delta forms when you have a river that empties into some kind of standing body of water. And all of the material that was being transported by that river stops moving and sinks to the bottom and forms these layers.
Our experience from previous missions is that this fine-grained material is good for finding clay minerals, which might then contain organic molecules.
You can think about water being trapped in little ponds and puddles around the place. That's the kind of complexity that can eventually tell you will lead to discovery of life.
Delta je suha vjerojatno 3,5 milijarde godina. Ali kako je izgledala dok je onuda još tekla voda?
I imagine if I was sitting on the edge of Jezero crater, just looking out over the lake when it was there 4 billion years ago, you would have this very peaceful environment. You might hear the sound of the river coming into the lake on the side where the delta is. It would probably just be this beautiful place. I would love to think that maybe there were some kind of fish or algae living in there. I would love to see us discover a fossil of some kind of plant, even if it's really unlikely. You never know. I wouldn't count it out.
We know that Mars was once a very different planet. But there has been a lot of changes happened on Mars since Jezero crater was formed and since that huge freshwater lake was deposited. Mars today, it's drier than the driest places on Earth. In addition, the very extreme incoming radiation would be an incredibly harsh environment, even for the most hardy microbes on Earth.
Kako je Mars postao tako nepovoljan za život? Odgovor na to pitanje daće naznake o tome gdje bi još moglo biti tragova. Stručnjaci su se usredotočili na kritično razdoblje kad je Mars imao rastaljenu planetarnu jezgru kao Zemlja danas.
Inside Earth, we have a molten core, and that spins around and generates outside of the planet the magnetic field. And that magnetic field protects our planet from the blast of ionizing solar wind coming off of our sun. Protects us, protects the whole biosphere. Now on Mars, it had that molten center just like Earth does today, but something happened on Mars where that started to solidify. Around 3.9 billion years ago, all of a sudden the magnetic field stopped and the solar wind blasted the atmosphere away. It literally blows it away. The moment the magnetic field was gone, ionizing radiation had a huge impact on the surface. And forevermore, Mars was a completely unique, different place.
Terensko vozilo Perseverance može postići najveću brzinu od samo 0,16 km na sat. Pretpostavlja se da će njegova vožnja do Delte trajati 2 godine. No, prije nego što počne potraga za životom, Perseverance vozi do obližnjeg graničarskog prostranstva regolita, gdje će ostaviti putnika.
Perseverance didn't go to Mars alone. It took with it this tiny little drone called Ingenuity.
Underneath the belly, Ingenuity is sitting sideways. The legs swing down, and then we drop to the surface. And from that moment on, there's no way to come back to the rover and reattach the umbilical. Our mission had begun.
Ovaj eksperimentalni helikopter mase 1,8 kg mogao bi se u misiji potrage za životom pokazati neprocjenjivim pomagačem iz zraka. Bude li radio?
There's a lot of challenges when it comes to flying an aircraft on Mars. One, the atmosphere, it's very thin. It's 1% that of Earth's atmosphere. There's almost nothing to generate lift with.
Još 2014. prvi se prototip borio sa simuliranom atmosferom Marsa u laboratoriju za mlazni pogon. Kako će se onda snaći na Marsu?
It's as if you operated it on Earth at 100,000 feet, at 20 miles high, and tried to fly.
Ingenuity was a total mystery to us. Was it going to work?
It doesn't carry any science payload. The one and only purpose of Ingenuity is to prove that we can fly on Mars.
A marsovsko je vrijeme hirovita varijabla koja bi mogla biti presudna za Ingenuity.
Mars can be a gusty place, and so we were not sure how that turbulence might affect this helicopter.
Za Ingenuity možda su najveća opasnost marsovska tornada.
We did see some pictures of Ingenuity with a dust devil in the background. Dust devils could probably do a number on that helicopter.
So today's the day of our first flight on the surface of Mars. We have sent the commands up the day before, and everyone's holding their breath. Definitely very nerve-wracking.
Equations tell you that you can get lift if you make it light enough, if you make the propellers big enough, but can you control the flight? That's another story.
Even taking off would have been a massive success. The sheer power of the rotor system to fight itself off the surface and produce lift, it was awe-inspiring. The plan for the first flight is take off, hover, come back down and land. That's it.
It came down on its feet, not on its side, and so we were really applauding.
This is big relief. We did it. Our mission is successful. We have proven we can fly on Mars.
Ingenuity is now off scouting for the rover. One of my absolute favorite ideas is to descend through a skylight hole into a lava tube cave on Mars. That was never thought to be feasible before this Ingenuity mission.
The fact that we flew this helicopter, this drone helicopter on Mars was really awesome for all of us.
Zahvaljujući svojoj vjeri u Ingenuity, NASA je sada mogla gledati Mars s neba. Potraga za znakovima drevnog života mogla je početi. Ali što bi to točno Perseverance trebao tražiti?
Scientists have been trying to define what life is for decades, and they still are talking about it. So there is no one clear definition.
The problem with looking for life is there's a lot of problems with it. The definition of life, it always uses the phrase alive somewhere in the definition of it, which is kind of circular, and it doesn't make any sense.
Looking for life on Mars, we have to make certain key assumptions. It would be really hard to recognize a form of life we've never imagined or encountered before. So we start looking for something familiar.
But the problem is that even here on Earth, where we have plenty of life to study, it's really hard to actually tell the difference between chemistry, complex chemistry, and life.
My idea of life is organisms actually change the environment. They do things. It's not like they deliberately think about doing this, but life chooses certain things that it wants. So when we go look for life, I look for indications of something very specific. That wouldn't be there if it weren't for life needing that specific thing.
Stručnjaci se mogu složiti u vezi s jednim, da naznake mogućeg drevnog života nazivaju biopotpisima.
Biosignatures are things that are left behind by life. So the thing that was alive to have produced whatever you're looking at isn't necessarily there anymore, but you can tell it was there based on traces that it left.
We're trying to find potential biosignatures, so we want to look for places that at one point had what we think life needs. So we're looking for hydrothermal material, minerals that could only be created in hydrothermal vents. We're looking for carbonates. We're looking for things that we know on Earth biology likes. If we found something that looked like a hydrothermal vent, we would stop and look at it for months, I would hope.
Hidrotermalni olušci, nastali nakon vulkanske aktivnosti, povezani su sa životnim procesima na Zemlji. Perseverance traži i zaobljene kamene tvorevine, zvane stromatoliti, obilježja najstarijih predjela na Zemlji.
So stromatolites are great because they're macroscopic. And I think they're like the tip of the iceberg that alerts you to, oh, hey, look here.
They are really rock formations, but they have within them organic carbon mixed with the rock layers that were the sediments.
Life on the Earth tends to clump, and on Mars we would expect the same thing. Lakes lay down layers, they lay them down flat. It's hard to imagine without biology how those things grow.
Život, dakle, može promijeniti izgled stijena. Biopotpis urezan u krajolik. Na Zemlji mikrobi mogu prouzrokovati i obilje nekih minerala u stijenama. Može li isto vrijediti i za Mars?
When you think about the things that life needs to survive, you probably think of water, maybe plants living off sunlight, but there are actually microbes that can live off of eating rocks.
If you ask a different scientist, you'll get a different answer. But my particular biosignature of interest is a family of minerals that are high in the element manganese. here on Earth, microbes absolutely love manganese because it has a lot of really critical chemical properties that they can use to actually do their metabolism.
Microorganisms have this amazing ability to adapt. They are capable of getting energy in so many unique ways. Give them a rock and they'll figure out how to use it.
Visoka koncentracija manganova oksida na Zemlji povezana je s prisutnošću drevnog mikrobnog života, a slična prekomjerna količina tog minerala još je u prijašnjim misijama pronađena na Marsu.
These minerals tend to form little bumps and crusts. You'll just roll up to a new spot and suddenly there is manganese.
Perseverance sad otkriva znakove novih naslaga.
As we look through SuperCam data, we can see that there is manganese in these rocks in Jezero crater. It literally is the very first time we shot a rock. You could see manganese in it. You know, this is very intriguing. It's not proof that life did this on Mars, but we can start looking for other things that can start building that case that maybe life made these materials.
Instrumenti na Perseveranceu predviđeni su zato da prepoznao jedva primjetan otisak mikrobnog života, kao i poznatu kemiju organskih molekula. Razorni učinak ionizirajućeg zračenja, složenost zadaće lociranja biopotpisa podiže na višu razinu.
We joke about the fact that it's planet bleach. Life as we know it needs water, an energy source, and organic carbon. But Mars is a very bad environment for a lot of organic molecules.
If there was life there, would that site have preserved the evidence in a way that we can find it today?
Poteškoće na koje nailazi robotska potraga za životom na Marsu mogu se činiti nesavladivima. Ali Perseverance je spreman zato da okrene situaciju u svoju korist.
If we're going to find evidence of life on Mars, we may get incredibly lucky and do it on Mars, but far, far more likely it's going to be in a laboratory with proper equipment back on Earth. And so Perseverance is an entirely unfamiliar kind of mission. Yes, we're driving around, we're looking at rocks, we're doing science on rocks, but it's being done to select samples, take small drill cores from those samples, put them in hermetically sealed containers, and leave them behind for a future mission that is only now being planned, an international mission to retrieve and bring back to Earth, hopefully within the next decade.
The sample is about the size of your index finger, and then you go and you unleash all the power of the laboratories on Earth and try and look at the even smaller scale.
This is really important because we can actually take those samples and look for signs of DNA in them. And DNA is irrefutable proof of life. We can tell you that it was not something that came from Earth, it was something completely native to the red planet.
Instrumenti na Perseveranceu rade usklađeno kako bi izdvojili potencijalne uzorke koje će ponijeti na povratku kući, ali u upravljanju posve novom opremom na Marsu pojavio se niz poteškoća.
The stress never gets any less. We're turning ourselves on today, and we're going to do some spectroscopy on the surface. I'm petrified that it's not going to work. I used to have an old car, and every time I would go out and turn the old car on, it's the same feeling. Is this the time the car is not going to start?
Mars opravdava svoj zaoglas negostoljubivog domaćina, jer i noć je samo još jedna opasnost koju treba savladati.
What happens is, as soon as the sun goes down, the temperature plummets. The metal that the rover's made of starts to contract. And it's like the arm starts to move and drift around, and that drift was actually not at all trivial.
Pixelu treba 17 sati za izradu detaljne mikroskopske mape površina stijena. Uzorak mora sve vrijeme ostati nepomičan ispod senzora, što je inženjerima zadavalo muke tijekom razvoja piksla.
So we actually had to invent a new thing called a hexapod, like a six-legged device, legs that would sort of get longer and shorter to make sure that you can stay the right distance from the rock and actually stay over the right part of the rock.
Inženjerska genijalnost stavljena je na kušnju 7 mjeseci nakon početka misije, kad ekipa mora odlučiti gdje treba bušiti za dobivanje uzorka. Prva je faza brušenje kamena kako bi se prije testiranja dobila čista površina.
It's really cool because you see a rock that's completely different than the rock you see on the outer surface. It's pristine, it's not weathered, it's not dusty.
You can see individual crystals. They're not tiny, they're actually really big. It looks like it's a volcanic rock. But there are some other smaller features that are a little bit harder to resolve. We have to go for a closer look.
Kad pretražuje površinu, piksel razotkriva 4 milijarde godina povijesti.
Pixel can make us an incredible map of the chemistry of this area. We can see that these smaller features appear to be salts.
Prisutnost soli znači da je stijena neko vrijeme bila pod vodom, ali nitko nije očekivao kalcijev fosfat.
What's so interesting about calcium phosphates is that they form in some very unusual environments on Earth. And in general, they're very closely associated with life. Phosphates have never before been discovered on Mars. And so that makes them incredibly intriguing to discover in Jezero crater.
Ekipa odluči bušenjem izvaditi jezgru iz kamena kako bi odnijeli na Zemlju. Taj uzorak mogao bi prekrojiti povijest Marsa, a neki čak vjeruju da bi soli mogle sadržavati mikroskopske količine jezerske vode.
These types of salty materials in rocks can preserve traces, little bubbles of water from when there was more water, when these materials were being emplaced in the rock. And so these little bubbles of water can preserve organic materials, so it's worth a look in these Martian samples.
Uzorak stijene pohranjuje se tako da bude spreman za slanje. Stavlja se u prvi od više od 30 cilindara namijenjenih laboratorijima na Zemlji. Oni su sljedeći korak u rješavanju tajne, nastale prije možda 4 milijarde godina.
All of a sudden, Mars goes through this incredibly dramatic change. Something on a planetary scale that we haven't experienced on Earth. Did life survive if it had been there? Life does things with its environment. We're looking for signs that organisms are actually influencing what's around them in a way that the natural environment wouldn't do so on its own.
The whole biosphere has affected the planet, have affected the mineral formation, everything. And that has got to be recorded in the rock, some way, shape or form, I think. There should be something that we can decode from that. It might take decades.
Mars is an entire planet, a planet like Earth, full of diversity of all kinds of things we can't imagine. So in a way, what I expect is the unexpected.
I'd like to know why Mars didn't have life or why Mars did have life. We're an exploration species and we want to know where we fit in the entire universe. Either answer is wonderful.
Are we alone? Is there life out there? Or is life so special that it's only here on Earth? We might find evidence of that randomness that defines the non-biological world.
If there is evidence of life having once existed on Mars, then that tells us that life can exist on a planet and then it can disappear. That's the reason why we're doing this. Can't rely on your planet to always provide your home.
Every time we look at Mars in a different way, we discover something grand. But do I think that the samples have evidence of life in them? It depends on what day you ask me.